Hello, everyone, and welcome. My name is Hila Goldenberg. I manage international collaborations at the Good Food Institute Israel. I'm very excited to be here and very excited to share with you the story of Israeli innovation in alternative proteins. First, I would like to thank the Israeli Economic and Commercial Mission to the Philippines for their collaboration and for this opportunity. In this session, we'll answer some interesting questions. What are alternative proteins and how they address some of the world's most burning climate and sustainability concerns? How do you make steak without a cow? How come over 1/3 of global investment in cultivated meat were raised by Israeli companies? And how did Israel become a leading global hub for alternative protein innovation? So before we dive in, it's important to understand the global context in which these technologies are now emerging. It all begins and ends with demand for meat. People love eating meat. Meat consumption today is the highest it's ever been, and it's expected to double by 2050 compared to what it used to be in 2005. We know today that by then, the world population is expected to reach almost 10 billion people, and they're all going to need to eat proteins. Of course, it's interesting to note that the population on our planet will grow by 60%, but demand for meat will grow by 120% over the same period of time. Part of the reason for this is that most of this growth in population will happen in low and middle income countries. These countries have entire populations that did not consume a lot of meat traditionally, just because they couldn't afford it. And now that they're becoming wealthier, we see a clear trend of increasing meat consumption in these countries. This heat map, for example, shows the expected growth in demand for poultry meat by 2030. So alongside with other countries, we can see the Philippines here, right on the right, in dark red. It's widely known today that existing methods of traditional animal agriculture are harmful. They pose challenges on our planet, humanity, and the global food system. For example, global livestock is responsible for almost 14.5% of global greenhouse gas emissions, which is more than the entire transportation sector in the world. It's the #1 user of freshwater resources on the planet, the #1 cause for deforestation. This industry takes about 75% of agricultural land. It causes massive land and water pollution, and it's also a major factor for public health risks in two aspects. First is antibiotic-resistant disease caused by extensive use of antibiotics, and second is zoonotic viruses that can be transferred from animals to us humans and cause pandemics. If we look at this production method and analyze it and its efficiency according to inputs and outputs, it's very clear that it is extremely inefficient. For example, let's look at the chicken. It's the most efficient one of all three animals here. In order to get 1 calorie out of the chicken, we need to invest and feed it 9 calories in. The animals basically digest these calories and use them to survive, breathe, walk, etc. So imagine this ratio next time you cook in your home kitchen. It's like whenever you want to make yourself 1 plate of food, you need to cook a quantity enough for 9 plates. Take 8 plates, throw them straight in the garbage, and just to be left with your 1 plate of food. So it makes you want to ask, is this really the best protein production method humanity could come up with? So gladly, the answer is no. Thanks to science, there is a better way to feed the world's growing population and to do so sustainably, efficiently, and safely. The idea is basically to make meat, but in a better way. We want the industry to meet consumers right where they are without making them compromise on the food that they like, by making products that are just as delicious, affordable, and accessible. There's very advanced technology that is used here to create products that are equivalent to traditional animal products in the way that they taste, smell, look, cook, to create the full experience that consumers love. And this is also why the Good Food Institute exists, and I'm happy to briefly tell you more about our organization. GFI is a science-based nonprofit organization funded 100% by philanthropy. We work globally to accelerate innovation in the alternative protein space. We have nearly 140 employees globally in 5 regions that were selected strategically, mostly around the large consumer markets like the United States, South America, India, Europe, Asia Pacific, and an office dedicated entirely to tiny Israel. And I think that speaks for itself, and you will soon hear why. We work with the scientific community, offer scientific advisory to companies, teach an academic course in universities, and fund open access research. We work with the business sector, from forming innovation strategies for the largest food corporates to supporting entrepreneurs throughout the entire life cycle of their ventures. And we also work with governments, promoting national plans for food strategies and working with government offices to ensure supportive policies and the fair regulation for the sector. So you can feel free to reach out to us for anything related to what I just mentioned. So as I said, a food system with much greater reliance on alternative proteins has the potential to substantially feed our planet. And by that, it addresses 9 of the 17 UN Sustainable Development Goals, the SDGs. And gladly, alongside with the environmental benefits, there's also a significant financial opportunity here. It is estimated that alternative proteins will reach 10% of the global meat market by 2030. So that's less than a decade, 8 years for this market to be worth $140 billion. By 2035, some sources predict a market size of $370 billion. Different forecasts give us different, slightly different numbers, but they all predict a very significant market size for alternative proteins. So let's dive in and see what are the main technologies behind alternative protein products. So if we want to create products that taste, cook, and feel like the products that we all know and love, first we would need to learn and analyze them. Analyze those familiar products. For example, the meat's natural biological structure, composition, physical properties. Learn things like what makes it juicy, what makes that fibrous texture, what composes the sensory experience of eating meat that people enjoy so much. And then use advanced scientific methods to recreate that using innovative technology. So we divide the field into 3 segments: products that are produced from plant-based ingredients, products produced using microorganisms via fermentation, and cultivated meat produced from actual animal cells that grow outside of the animal's body. So plant-based, when we say plant-based meat, that means making meat out of plants, right? This may sound simple, but we're not talking about tofu or bean burgers here. The idea is to harness the most advanced technologies to create products that mimic animal-based products in everything that we love about them. The flavor, the texture, the mouthfeel, the sizzling effect, the juiciness, the cooking functionality, and everything associated with that experience. And if we look at the value chain here, we can separate the process of manufacturing plant-based meat into 4 high-level steps. First, we need to choose the right plant, the best source material. So this could be wheat, soy, peas, chickpeas, or even fungi and algae. Then we optimize that source to make it more suitable for a plant-based meat product. For example, increase the protein content or reduce the beanie flavors. And in Israel, there's a good expertise in that. At the second step, the raw materials are isolated from the source material. Then they're optimized so that they could serve as an ingredient in the final product. For example, if we just want to use the protein or fiber, we need to isolate them, and then we need to make it suitable for industrial use. Finally, the end product composition. So this is where art and science come together and combine these ingredients to create the desired taste, texture, smell, and appearance. So this is often done in a process called high moisture extrusion that's used to create the meat's fibrous texture. This is a capability that is highly needed in the Israeli industry. And in fact, there's a need for innovation in each of these steps that I just mentioned. In fermentation, we use microorganisms to change the chemical composition of other materials to create the proteins. Fermentation is actually something that's been around in the food and beverage industry for a very long time. Yogurt, beer, baking with yeast, these have all been around for a while. But now this technology is increasingly being used in the alternative protein industry to create both ingredients and standalone products using microorganisms such as fungi and bacteria. So that way fermentation can be used to alter the chemical composition of plants into a product that can make a source of protein. When it makes a source of protein on its own, this is what we call biomass fermentation, like in the case of fungi-based products like corn, for example. Another type of fermentation is called precision fermentation, a process that can produce enzymes, flavoring agents, vitamins, natural pigments, and fats to be used in alternative protein products. This could be either plant-based or cultivated. A good example for fermentation is the Israeli company Remilk. They use yeast to create milk proteins. Their microorganisms are reprogrammed to express whey and casein proteins, which are chemically identical to the ones found in cow milk. Cultivated meat, that's actual meat, just made outside of the animal's body. The technology behind cultivated meat is borrowed from the cell therapy industry and the scientific field of tissue engineering. A biopsy of cells is taken from an animal without harming it. The idea is to have the cells grow in the same way that they would inside the body, but in a bioreactor. In this process, we provide the cells everything that they need in order to grow, whether it's temperature, nutrients, etc. So we can see in the slide that the cells that were taken from the cow are isolated, expanded. Then the cells differentiate into muscle cells, fat cells, and connective tissue as they mature, all outside of the animal's body. So this process will take around 6 to 8 weeks, far faster than the time required to raise an animal for slaughter. And today, the main efforts for the leading cultivated meat startups are invested in scaling up in a cost-effective way. By 2025, we're expected the regulation approval in several regions and significant cost reductions. And then by 2030, we expect to see operational industrial scale facilities for cultivated meat. So who are the target consumers for alternative proteins? We've seen over the years that the percentage of vegans and vegetarians really doesn't change much. It stands at around 6% of the population. But the number of flexitarians is growing, and it's them, along with the omnivores, that this new wave of companies is targeting. So in order to understand everything that's happening in Israel, let's take a quick glimpse on the global scene. This is what the entire global industry looked like in 2018. And in this map, this is basically a snapshot of the ecosystem 3 years later in 2021, already in January. And you can see a big bang of startups, incubators, large corporates, and investors from all around the world that have entered this field and are getting increasingly involved. Private investments are skyrocketing, and they almost tripled in size in 2020 with $3 billion invested in alternative proteins. We're still summarizing 2021 at GFI, but we expect this number to reach about $5 billion for last year. And it's important to say that even though we see such a boom in the number of companies, this is still a very nascent field, and there is still a lot of room for innovation and challenges to overcome on the way to making products that actually taste, cook, and cost exactly like their conventional equivalents. So this is true for all three technological segments. So let's dive in. Time is short, but I hope to fulfill my promise from the beginning of the session and tell you how Israel has positioned itself as a global leader in alternative protein innovation. Here are a few numbers that demonstrate this leadership. Here on the right, you can see that investment in 2021 in the field grew by about 450% compared with 2020. Keep in mind that Israel's size when looking at these numbers. Israel is leading in the number of alternative protein startups and is ranked second in the world in cultivated meat and fermentation categories with 12 startups in each of these technologies, Over a third of global investments in cultivated meat in 2021 was raised by Israeli companies. We're also leading in alternative protein seafood innovation, everything related to alternative fish and seafood. And Israeli company Future Meat raised the largest investment in cultivated meat in history, and that was $347 million. In 2021, we can see that growth across all sectors was fueled by companies reaching the commercialization stage, expanding their operations, targeting global markets, alongside with an increase in the number of new companies. One of the main reasons for Israel's flourishing ecosystem is the Israeli academic research. The science of alternative proteins is very interdisciplinary, from food engineering to biotech and tissue engineering, plant science. We have over 30 labs in Israel that are active in the field of alternative proteins right now. This is a relatively high number when comparing to other countries. And there's also, you can see here a lot of potential for growth. At GFI, we've mapped all the research labs in the country and found that there are 300 additional labs that are relevant and interested in dedicating the research to alternative proteins, but they just need more funding in order to do so. So we at GFI are working with stakeholders across the ecosystem in order to fulfill this potential. The startup ecosystem in Israel is also flourishing. We can see that there are nearly 50 startups in Israel across the 3 technological segments in different levels of maturity. We have 12 cultivated meat companies that we can see here. None of them is in the market, but they are getting closer. Super Meat, Future Meat, and Olive Farms were among the first in the world in this field and are working now on their pilot and scale-up. In fermentation, here we can see a variety of startups. Most of them are in the development stage. We can see companies like Chunk that develop whole-cut meat analogs, to Kinoko that developed a unique product based on mycelium produced through biomass fermentation. We also have Remilk that we've mentioned before. This focuses on dairy proteins, and a lot of other companies. In the plant-based category, in this field, we have quite a lot of startups that are already in the market, mainly ingredients such as Chickpea and InnovaPro, who focus on chickpea protein, but also Redefine Meat, who focuses on 3D printed plant-based meat. They've recently launched. Yo, who develop plant-based eggs, Plantish, who develop plant-based salmon, and many others. What's even more interesting is that we know of about 30 additional early-stage startups in all 3 segments that are still in the pipeline and just under the radar, and we expect to see them join this list within the next couple of years. So alongside the startups, there are also 9 incubators that operate in the alternative protein space. Some of them are backed by the government and also backed by large corporates. So the Israeli entrepreneurial landscape has seen some important strategic partnerships with global industry players who are getting increasingly involved in this space. We can see here names like BRF, one of the largest meat producers in the world, Nestle, the world's largest food company, Tnuva, Israel's largest food company, and Pluristem. They've actually just announced that they're launching a new cultivated meat company. Strauss is also a large Israeli food company, partnered with Belgian company Alpro, which is the world's leading producer of plant-based dairy products. We see Migros here from Switzerland. It's basically the country's largest food retail group, and others. So we can see here that alternative proteins are the fastest growing technological field in terms of investment in Israel. But it's also a very nascent field. We're still very early on this journey. There's still a lot of more room for growth, also in terms of investment. So it's still a good timing to join and get involved. So we've mentioned the multidisciplinary academic research. We've mentioned Israeli companies' access to private capital and collaborations. And of course, there's also the entrepreneurial spirit that the startup nation culture that's very strong here in Israel. But there's also another important factor in the advancement of the Israeli ecosystem, and that's the support this field gets from the Israeli government, from the different ministries to the Israeli Innovation Authority, that provides increasing support for alternative proteins. A few examples. Here on the left is the former Prime Minister Netanyahu becoming the first Prime Minister to try cultivated meat. 1 year later, Prime Minister Bennett, you can see him here in the middle, he got appointed and presented Israeli innovation in alternative proteins to President Joe Biden in their first meeting, basically putting this climate solution in the spotlight. And also last year, Israeli President Herzog enjoyed the Future Meats cultivated meat together with the Minister of Environmental Protection. You can see them here in the picture. And this involvement basically demonstrates how central this field is in Israel's value proposition to mitigating climate change. So lastly, opportunities for getting involved for companies. So first, there's R&D partnerships and pilot manufacturing partnerships. Israel is a small country. Some infrastructure is still missing here for both R&D and manufacturing. Equipment and the capabilities like high moisture extruders, fermentation, manufacturing facilities, bioreactors, spray drying, etc. Israeli startups are looking to partner with large companies, not necessarily in the food space, but also companies from other industries like pharmaceuticals, from basically all the way to even beer. Partnerships can push this sector forward and allow startups to scale faster and shorten their path to market. R&D partnerships will preferably be with access to infrastructure. There's still a lot of room for innovation in all three technologies, with a few white spaces that are highlighted here. You can see them here on the right. Fat biomimicry basically means developing new sources of fat that mimic animal fat. Crop optimization, developing new strains of crops optimized for the alternative protein industry. Seafood alternatives in all three segments. In cultivated meat, they could be plant-based or even fermentation derived. Texture formation processes. This could be either improving extrusion cooking that we've mentioned earlier in this presentation, or alternative methods for texturization. Also opportunities for investment. Of course, a lot of companies in the industry are looking for investments, mostly for their scale-up rounds. Go-to-market and commercialization partnerships are also sought out for. Basically, Israeli companies need partnerships overseas for getting themselves closer to the consumption markets. And there's also a lot of room for international collaborations and opportunities. So with that, we've reached the end of the presentation. You're welcome to log into our website at either gfi.org or gfi.org.il. You can find there additional resources, databases, reports about alternative proteins and the ecosystem, and you're also welcome to reach out to me. So thanks again, and you're welcome to ask any questions after this session. Thank you very much.